So this is the 2014 Leaving Cert Higher Level Paper 1, and we're looking at question number 4. Differentiate the function 2x squared minus 3x minus 6 with respect to x from first principles. Okay, so to differentiate from first principles, we need to set up the following. We need to find the limit as h goes to 0 of f of x plus h, so h is the small increment, minus f of x all over h. So this is what we're trying to set up. So we have three things here that we need to work out: f of x plus h, f of x, and then h, which is just h. So firstly, I'm going to try and work out f of x plus h. Well, the function f of x is 2x squared minus 3x minus 6, so f of x plus h will be replacing these x's with x plus h. So that's going to give me 2 bracket x plus h squared minus 3 bracket x plus h minus 6. Okay, so that's going to give me 2 bracket x plus h squared, which is x plus h by itself, minus 3 gets multiplied by each of these, so that'll give me minus 3x minus 3h minus 6 still there at the end. And that's equal to 2 times x is x squared, h by x is hx, and another h by x is 2hx. So finally the h times the h is h squared minus the 3x minus 3h minus 6. Still some to do, so I'm going to multiply the 2 by each term inside the bracket here. So that gives me 2x squared plus 4hx plus 2h squared minus 3x minus 3h minus 6. So, is there anything here that I can combine? I don't think there is, so I think that's us done. There's no terms here that we can combine, so that's actually f of x plus h. Okay, so that's this part. Now I'm going to do f of x. Well, f of x is what's given in the question. F of x is simply 2x squared minus 3x minus 6. So f of x plus h minus f of x. So if I subtract this from the above, f of x plus h minus the f of x, well, the 2x squared minus this 2x squared, they disappear. I've got minus 3x, take away another minus 3x, so they disappear. And I have the minus 6, take away the minus 6, so they disappear. So I'm really left with 4hx plus 2h squared minus 3h. So I'm now going to sub this up here for the numerator. So that's going to become the limit as h goes to 0 of the numerator now has become 4hx plus 2h squared minus 3h, and that's all going to be over h. So I can see I can cancel h's above and below here, so h into h goes once, that h, I cancel one of these h's, leaves me just that one, and that h goes as well. So I'm left with the limit as h goes to 0 of, on top I've got 4x plus 2h minus 3, and underneath I've just got 1, so it's no need to write that. So finally then, the limit as h goes to 0 of 4x plus 2h minus 3. Well, if I imagine that this h goes towards 0, well then 2h will go towards 0. So I'm just left with 4x minus 3. So that's it, differentiated from first principles. And I can just check here by using the differentiation rule. Bring this power to the front, multiply by the 2, so that's 4x to the power 1 minus 3, or 4x minus 3. So I know I've done it correctly. Okay, part B. Let f of x equals 2x over x plus 2, where x cannot be equal to minus 2 and x is an element of the real set of numbers. Find the coordinates of the points at which the slope of the tangent to the curve y equals f of x is 1/4. So the slope of the tangent to the curve, well, the slope of the tangent to the curve is the derivative, or f dash x. So we're going to let f dash x be equal to 1/4, because f dash x is the slope of the tangent to the curve. That's what it is. So we're going to find f dash x and let it be equal to 1/4, solve for x, and then that's going to be the x part of the coordinates, and then find the y coordinates from the original function. Okay, so f dash x then. Well, f of x is 2x over x plus 2. So this is a function of x over another function of x. So this is going to be the quotient rule. So I've taken the quotient rule from the tables book. It's down here. So we're just going to match 2x is our u, and x plus 2 is our v. So the quotient rule says that u is the 2x, so du dx is the derivative of this, which is 2. And I let v be x plus 2, so dv dx is just the derivative of this, which is 1. So now I'm going to sub these things here into my formula for f dash x, or dy dx. So I'm going to have v du dx, so that's going to be this times this, so x plus 2 times 2, minus u dv dx, so minus u is 2x, and dv dx is 1. And that's all over v squared. So v squared is x plus 2 squared. And we know that that's equal to 1/4. Okay, so we're going to tidy up here on the left. The 2 gets multiplied by each term in the bracket here, so that's going to give me 2x plus 4, and then minus 2x by 1 is minus 2x, all over. I'm not going to multiply this out just yet, I'm just going to leave that alone, which is equal to 1/4. Okay, so on top here, the 2x minus 2x becomes 0. So I'm left with 4 over x plus 2 all squared equals 1/4. So I have a fraction equal to a fraction. Now when you have that situation, a fraction equal to a fraction, you are allowed to cross multiply. So I can multiply the numerator here by this denominator, gives me 16, and then this numerator by that denominator, giving me 1 times this is just x plus 2 squared. Okay, so I've now got an equation in x. I can multiply out x plus 2 squared, bring the 16 over, create a quadratic and solve. But I can see here that both sides are squares. So what I can do here is square root both sides. So I can say that square root of the right side, that's x plus 2. The square root of x plus 2 squared is just x plus 2. And that can be equal to the square root of 16. But I must account for the positive and negative value of that. So square root of 16 is actually plus or minus 4. So we look at both situations. If x plus 2 was 4, and then we look at if x plus 2 was minus 4. So if x plus 2 is 4, that means x must be 2. And if x plus 2 is minus 4, bring the plus 2 over, it becomes a negative, and we get x is equal to negative 6. So there are my two x values. I was asked though to find the coordinates of the points. So I've got the x component of the coordinates, I just need now to find the y. So I'm going to plug my x values into the original function. So I can plug them in here. So it's 2x over x plus 2, so I'm going to do this over here. So f of 2 will be equal to 2x, which is now 2, so 2 by 2, over x, which is 2 plus 2. And that gives me 4 over 4, which is 1. So one of my coordinates then will be 2, 1. And then I'm going to find f of negative 6, which is going to be twice negative 6 over negative 6 plus 2. That's going to give me minus 12 over minus 4, which is 3. So my other coordinate then will be minus 6, 3. So there we have the coordinates of the points at which the slope of the tangent of the curve is a quarter. So that's the end of question number 4.